So today I have the pleasure of introducing the Ethereum Explained talk. We have a great trainer today. He fell down the crypto rabbit hole in 2012 after learning about Bitcoin. 2 years later, he founded the Ethereum Denver meetup. He's an ETHDENVER steward and the head of R&D at ShapeShift. So please help me welcome Kent Barton.
Cool, thank you, Shannon. Check. Can you guys hear me? Okay, cool. Thanks, Shannon, for the intro, and thank you guys for being here. It's a real honor and privilege to present to you guys. I've been at a lot of conferences, and this one seems unique in the sense that it's all about education. So thanks to C4 and all the volunteers. This has been so much fun just to get ready for. So yeah, I've had quite a fun and eventful journey in crypto so far. Currently, I'm at ShapeShift doing R&D. We have some foxes over there. Hello. And a lot of that work focuses on some of the current challenges in blockchains. When I got into crypto in 2012, I thought, man, I feel like I'm getting in ahead of the game. Bitcoin was already out 3 years. I felt behind the curve, and so much has changed since then. So one thing I want to stress, if you're just learning about this technology now, we're still very early in the game. You know, in 20 years, once this sort of thing is well adopted in mainstream society, then okay, maybe that's not ahead of the curve. But you learning now, it's still very early. So originally I conceptualized this as kind of like a 30,000-foot view of Ethereum, but it occurred to me that Ethereum is global in nature, so let's pull back to the altitude of the International Space Station, which is 250 miles. Ethereum really is kind of a decentralized and global thing, much like Bitcoin. It doesn't have borders, it doesn't have a central point of authority, and it kind of just speaks to kind of the nature of it. We're also going to do a high architectural overview. We're going to cover some general concepts. My goal is just to position you to start your own journey and move down your own rabbit hole. We won't be getting overly technical. There's some other talks after this at the conference that pertain to that. But you will have a good sense of some of the key things that make Ethereum tick. Before I continue, last night I was talking to Taylor from My Crypto, and it reminded me that I had not added any memes in my presentation yet, and that's perhaps the most important thing. So, okay, there's Business Cat, and I'm a fan of this one lately, like... Thank you, I'll be here all night. Okay, that said, memes out of the way. In order to get a sense for what Ethereum does and why it exists, it's helpful to jump in a time machine and go back to the year 2012 or 2013. So back then, Bitcoin had been around for a few years, and it was clearly becoming a thing. It had survived big ups and downs and some early drama, and it was becoming apparent, okay, it's not a scam, it's not easily hackable, it's very good at actually protecting value and transmitting value. So at about that time, people are thinking, well, given all this technology, what if we could do more than just secure Bitcoin? What if we could assign value or have tokens that represent a whole variety of assets? Maybe you could have a digital gold on the Bitcoin blockchain, or maybe you could even represent a share of IBM. So this was talked about for a while. The original concept was called colored coins, where you could kind of build on the Bitcoin network and have assets represented as tokens. This eventually led to a concept called Mastercoin, which still exists in the form of Omni network. Omni is the base layer for the Bitcoin version of Tether. So that actually is still around. Around that time, in 2013, a guy named Vitalik Buterin, who was the editor-in-chief of Bitcoin magazine, was working with Mastercoin. He also saw the limitations of Bitcoin and wanted to expand on that. I remember looking at a Google Doc once around then and looking at the Mastercoin stuff, and Vitalik was in there like doing live comments. I thought, this is pretty cool. You know, this is going to work out to be something. But a little bit later, kind of mid to late 2013, Vitalik came to the realization that these limitations inherent with building on Bitcoin were maybe too onerous. And maybe the better approach would be to borrow from some of the key concepts that Bitcoin has, and then crucially, have a departure where you could do something else. And that's namely arbitrary smart contracts that execute code on the blockchain. So this is a whole different blockchain, a whole different pivot. He described this in the white paper that was released in late 2013. It doesn't look super yellow on the right, but that's the yellow paper by Gavin Wood, and he actually gave computer science muscle to Vitalik's concepts. He described how the Ethereum blockchain would be actually put into operation, how it would work. So these two pieces really form the basis of Ethereum. Kind of at the onset, and this holds true today, Ethereum has one or two central unique value propositions. But the key thing to understand is it's building on the shoulders of giants. It's building on Bitcoin, which itself was a remarkable revolution and evolution in technology, building on cryptography and other things. So it shares much with Bitcoin. And these are the fundamental properties that you really want with any fully decentralized or maximally decentralized technology. Censorship resistance, no third party can shut it down, whether it's a government or a company. Immutability, you can't go back in time and say, well, actually, that was, I sent 2 Ether to you and not 1 Ether. It's immutable. Trustlessness, you don't actually have to trust a third party because you can trust this decentralized distributed network of nodes and miners. Permissionlessness, you don't actually have to ask permission to do anything on it. All you need is, in this case, Ether to interact and power smart contracts. You don't actually have to be beholden to anybody to do anything. And finally, transparency. As much as you hear about, people are using crypto for drugs and to fund terrorism and these various awful sounding things, the fact is almost all cryptocurrencies by default are transparent. Everything that happens on the blockchain is visible. That doesn't necessarily mean that your address is tied to your identity, but it's increasingly easier for authorities to figure that out. The transparency has some big benefits in terms of you can know exactly what's happening, what's going to happen with the smart contract, and all sorts of other good stuff. So onto this wonderful thing that Bitcoin had created, Ethereum adds a Turing-complete global platform. Turing-complete is a fancy computer science term. Really, to me, it's kind of like you can build a lot of arbitrary things on it. You aren't limited to just a few. You aren't locked into a few things. That enables smart contracts, the definition of which we'll cover shortly, and also decentralized applications. Who here has played with like at least one DApp before? Okay, cool. Not too many people. I would hope and I suspect that maybe in 5 years, everybody will raise their hand, almost like as if you're asking if. Have you ever played with an app on your phone? Everybody has. But there's some challenges, and we'll cover that as well. So, okay, that sounds cool, but so what? Why is this actually interesting, and why is it revolutionary? Ethereum empowers users with abilities that did not previously exist. So this includes tokenized crowdfunding. This was the original use case of Ethereum. In fact, when Ethereum launched, this was on the site as something you could do. They even provided the code. This turned out to be wildly successful and fueled the ICO bubble that everybody's so familiar with. Of course, that got very hype-driven and had its own sort of economic issues. But technologically speaking, the ability to create tokens and then have people pay for them and then use those tokens in an application turned out to be revolutionary. Decentralized exchanges, many, countless centralized exchanges have been hacked. It'll happen again, I absolutely guarantee it, when you have these honeypots of a lot of money. Decentralized exchanges instead rely on smart contracts to protect wealth. They're not holding your funds. It exists in these open smart contracts. DAOs, you might hear the term DAO. It's decentralized governance, a little bit beyond the scope of this talk. But it's kind of a new way to achieve governance for organizations. Tokenizing real-world assets. I just saw the other day that a company is tokenizing actual real estate on the Ethereum blockchain. So why bother with that? You could have increased fungibility. You could also have fractional shares of assets that you normally couldn't have. In other words, imagine if you wanted to get exposure to real estate but you didn't want to buy like an entire house. Maybe you want to buy a tenth of a house in Denver or somewhere that you thought the market was going to go up. Suddenly, with tokenized real-world assets, this becomes possible. This is an emerging thing. It's not common yet, but I think that's where things are headed. And then stablecoins. Stablecoins are a really interesting and useful thing. Not limited to Ethereum. The Bitcoin version of Tether lives on Omni that we talked about earlier, but they really lend themselves well to Ethereum, and there's a whole host of stablecoins on Ethereum. And what these do is they provide you the ability, or all the benefits of a token on the blockchain, but without the insane volatility that we're all used to in crypto. If there's one thing you can count on in crypto, it's high volatility. So let's dig into three really important concepts. And again, this is kind of this is a high-level overview. There's much more complexity, but in my humble opinion, if you need to know really three things about Ethereum, it's the following three things. One is consensus, and this is where Ethereum shares a whole lot with Bitcoin. This concept of a distributed system where you have a variety of like thousands of nodes, each running a copy of the software and processing all the transactions and running all the codes. Additionally, you have miners who are incentivized to secure the network and publish new blocks. This is a proof-of-work mechanism. It works great with Bitcoin, and it's worked great with Ethereum, although there are plans to change it in the future. We'll touch on that in a little bit. So the design decision to do this was pretty smart because it was a proven sort of thing, and it's actually worked out quite well. The idea with having thousands of nodes running the software is that if a miner gets clever and tries to slip a transaction through and say, actually, I'm going to send myself this money instead of this person, or otherwise change the code, it's effectively impossible because all it takes is for one of these nodes to reject that transaction. Everybody's running the same software and the same code. This also presents some scaling challenges, but there's upcoming solutions to that. So here is where we have a fork in the road and we have a departure from Bitcoin. This is a very notable departure. Bitcoin has what's called opcodes, and I may be a little bit off here, but I believe it's probably a few dozen that are commonly used. And these are instructions that you can use to do things with Bitcoin, like maybe lock up money for a certain period of time and a few other things, but it's very limited. And this is one of Bitcoin's strengths because its simplicity helps it be more secure. It's why you haven't heard of Bitcoin just getting hacked or some major consensus failure. However, it's one of its notable limitations because you really can't easily do a lot with it. People have tried; it's very clunky. So Ethereum, the number one first actor, the shining golden first actor or citizen in Ethereum is the smart contract. A smart contract does not have any sort of legal connotations. Some people get a little bit confused and say, well, wait, contracts? It doesn't refer to any sort of legal thing, but more so to this idea of a snippet or a piece of code that will execute a certain way. It lives on the blockchain, and by virtue of its transparency, you can be sure it's going to execute how it says it will. You can analyze the code before you use it and say, yes, in fact, this decentralized exchange will swap this for this, and everything looks good. Third parties can audit it, and it triggers on the blockchain via if you have your own Ether, typically that's held in just a regular account. So that's a second type of account in Ethereum, and then the other one is the smart contracts. So you could send Ether from your own account, and also smart contracts can trigger each other, and then this code happens, and hopefully everything goes well and as intended, which there have been incidents where there were some issues, and we'll cover that as well. Just to dig in a little bit further, a lot of you have on the developer side may have heard of Solidity or experimented with it. There is a variety of languages you can program in with Ethereum. Solidity is by far the most common because it was built on it's like a JavaScript variant. I think this was another really good design decision they made in the early days. Given the fact that JavaScript is so popular, let's build this Ethereum type language around it. So it turned out to be a wise move because it's engendered a lot of developer participation, and it's easier to get your head around. Of course, you still have to understand some of these blockchain concepts as well, and there's some differences. But in general, it's not bad. It's people enjoy programming in it, and it's been successful. There's also other variants like built around Rust and Python if you want to branch out into other things. But Solidity is the most common. So what happens then, you see on the left, it kind of looks like your typical code. On the right, you see basically low-level assembly code, and this is the very bare-bones instructions that's getting fed into what's called the EVM, or Ethereum Virtual Machine. The EVM is really where the action happens. This is behind you open the hood, and when actual data is being sent around and things are happening, it's all about the EVM that's making these instructions happen. You can see this is not human-readable code, but that's okay because it just compiles down to that code. So let's visualize that a little bit more. And again, this is simplified. It's pretty high level, but this is essentially what's going on when you're using Ethereum. So imagine you have a Solidity code representing, say, a smart contract. When that's activated, it's compiled down into EVM bytecode. These are the instructions, and then that in turn has the Ethereum virtual machine do something. And then if you've actually done everything right and you've paid for the smart contract via gas, which we'll cover next, it will execute, and then whatever actions have transpired will be codified in the next block, and that's that. And due to its immutability, at that point, the outcome of the smart contract is effectively set in stone. If it's not, if something got reverted, then something has gone dramatically wrong with Consensus. This has happened with other smaller blockchains. To date, it has not happened with Ethereum or Bitcoin. But at that point, you have the deployed contract, and things are, humming along nicely. So we come to this concept of gas. There's a site called EtherScan where everything is transparent on Ethereum, so you can see exactly what's happening. In this case, a smart contract was called. However, it ran out of gas, much like your car might, unless you have a Tesla. And the reason is the user, for whatever reason, did not apply sufficient gas to the transaction. So gas is the fuel that powers Ethereum smart contracts. Why is fuel even necessary? Like when you're playing a video game or running a database locally, you don't need any fuel. The reason is every computational instruction on Ethereum is priced in gas. If there wasn't gas, then you would have crazy situations like infinite loops, contracts running all the time, and this would basically clog the network and make it effectively unusable. As an extra thing, it incentivizes miners to protect the network because they get the fees as well. So it's preventing infinite loops and other kind of disasters that can happen with code that doesn't require fuel, and there's the incentivization aspect as well. So one other important thing to know with gas is it is not actually Ether. However, it's priced in Ether, and this can take a while to get your head around. Let's say you send a transaction to, or maybe you want to trigger a smart contract, and you send an ETH into one Ether into the smart contract, and maybe the gas is totals up to like 0.01 ETH. So you're certainly paying an extra 0.01 ETH, but what's happening behind the scenes is it turns that into gas, and you're not actually powering the contract. Like gas it's not tradable on the free market. It just happens behind the scenes. It kind of feels like an extra layer of abstraction. Like why did they bother with this? And the reason is to decouple the fluctuations in the real world value of Ether, which can gyrate in a crazy way, with the actual need for gas. Otherwise, then it would get more onerous to use Ethereum as the price of Ether went up. Instead, miners themselves can decide what's an okay gas amount, It's kind of a market that miners set themselves, and it does fluctuate heavily with supply and demand for the network. And we've seen this many times when the network got overloaded. Did anybody hear about the CryptoKitties debacle? So that was CryptoKitties right there. The network got way too popular, way too fast, and it got very expensive to use because gas prices went up. When all is running well, gas prices are stable and pretty negligible. But this is that decoupling is a smart, I think, move by the dev team to kind of deal with the volatility issues. And by the way, if you have questions as we run through this, I'm going to probably talk until maybe about another 15 minutes, and then we'll have time for Q&A. So given all this, we kind of talked about some of the theoretical stuff, but let's talk about what's happening now. Because in my opinion, there's a lot of interesting things going on. And I just want to highlight a few interesting decentralized applications. And a decentralized application is sort of a combination of smart contracts that live on the blockchain, plus an interface, a front-end interface where users can interact with the DApp. Kind of like your regular phone app, but on the blockchain. So Maker, they are the guys that do the DAI stablecoin. Maker's been around for quite a while. DAI is a decentralized, algorithmically reinforced stablecoin that's become very popular. Just the ability to have to insulate yourself from volatility risk is wonderful if you're interacting in crypto or holding crypto for maybe commerce purposes or other things. Interestingly enough, it's also powered this really cool thing called DeFi, or decentralized finance. DeFi has become a little bit buzzwordy lately because it's just like it's the new hot thing, but I think there's really some substance behind it, and a lot of it is based on the fact that people now have the ability to earn interest and do cool things that's denominated in a stable value. So as an example, Compound, it allows you to lend out tokens and then get interest that's denominated in various tokens, including DAI. And this is spawned, if you just Google DeFi apps, you'll see all sorts of cool examples of things that are happening. It's gotten very far out. Some people call it money Legos. Some more cautious people say, well, look at what happened with derivatives in 2008. We don't want to recreate that. It's how down the rabbit hole we're getting with this stuff. But something to keep an eye on. It's very cool. Gods Unchained is I mentioned CryptoKitties, but this is a more recent example of gaming on the blockchain. Gods Unchained is kind of like a Magic the Gathering collectible card game. The key distinction here is you own all your cards in a provably fair way. In other words, you have this private key that's associated with a token. That token represents a specific card. So that allows you to create markets for these cards and trade them with friends and actually have self-sovereign ownership of these assets. Gaming is an increasingly huge market, billions and billions a year, and in-game economies, even without the blockchain, are a thing. So with blockchains, you can imagine, well, maybe I have this really cool sword, and I want to use it in another game, and this allows for more cross game assets potentially. And crypto also lends itself well to micropayments, which are common in in-game economies. Basic Attention Token is definitely one of my favorites, just because it addresses, I think, one of the biggest failings of Web 1.0 and 2.0, and that's the fact that the ads experience is awful. It's a horrible experience. If you're a fan of reading sites online, news sites, or whatever sort of content, you're probably sick of paywalls. You don't want to sign up for these things. However, publishers are also losing money. It's kind of a lose-lose situation for everybody involved. We've seen a lot of online newspapers shut down. Maybe they were formerly real newspapers. It's just an ugly situation. So BAT, or Basic Attention Token, it's integrated with the Brave browser, which has some cool non-blockchain privacy aspects. But what this allows you to do is incentivize and reward your favorite publishers with this micropayments of this token. It's a cool concept, and again, this was not possible prior to the blockchain. Sending micropayments in this unique token in response to different things. BAT has teamed up with Reddit, Wikipedia, a lot of other big organizations keep an eye on them. They're pretty cool. Finally, Augur is a decentralized prediction market. They were the very first ICO. Back then, it wasn't even called ICO, but they were the first crowd sale on Ethereum after Ether itself. It's a decentralized prediction market where you can bet on elections. You can bet on, just about anything, sports. And here we see the value of censorship resistance. Prediction markets are not new. They've been around. There used to be a site called InTrade, but it's easy for them to be shut down, maybe in the local jurisdiction. It's seen as gambling, or, and this is very crucial, it would be easy for a prediction market to maybe skew the results or abscond with your funds. In a properly implemented prediction market on the blockchain, this is not really possible. There's no censorship, and there's no, the transparency means you can kind of understand exactly what's going to happen. Augur has had some UX challenges, and they have yet to really take off, but I think that will come in time. They have a really good team, and it's a cool project to check out. Okay, so this is all very exciting, but what could go wrong? It turns out quite a lot can go wrong when you have an experimental blockchain that's only been around for like 4 or 5 years, and you have these crazy smart contracts. This is how people that invested in the DAO felt in 2016. The DAO, you may have heard about this hack. It was an ambitious, cool project where people were going to tap into this way to have decentralized governance, to fund things. It was really ambitious and fun. People just poured their money into it, millions and millions. It was really cool. Then one day we woke up to see that the contract had been drained of millions of value. So somebody was actively draining it. You could see it before your eyes. It turns out the smart contract code had flaws. It was not written very well. And it's kind of understandable, like this hadn't happened before. It was a hell of a stress test. And millions of dollars of value were lost to this unknown hacker. So this actually led to a very confrontational and controversial split in the Ethereum community. Some of you have heard of Ethereum Classic. The way this resolved is the community said, well, okay, this is sort of a mulligan. We're going to just revert those transactions that led to the hack because it was viewed as too handicapping to the ecosystem. Ethereum Classic said, you know what? Code is law, let the hack happen, and then that kind of split off. So that's sort of what led to that. But more to the point of this topic is just the dangers that come with holding value in smart contracts. This happened again a few years ago when there was a multi-signature contract, like a wallet contract, which ostensibly a multi-sig should be much more prone or hacking proof because you need to have multiple signatures to release the funds. A group called Parity had a multi-sig wallet with millions of value, and it got hacked in a way that all the funds in there were frozen. I believe this happened twice. So in this case, there was no bailout. The community was very firm about, okay, no, there's not going to be another sort of DAO here. And it sucks, but anybody that had their money in that multi-sig contract, they lost funds. So this does not exist in other sort of implementations, or this doesn't happen like if you bank online at Chase, you don't have to worry about, well, they screwed up and they sent my money somewhere else necessarily. And if they do, they can always revert the transaction. This is a weakness and something that needs to be addressed with Ethereum. There are solutions underway, namely formal verification, which is a way to really ensure mathematically the code will execute as it says it will. There's also languages like Haskell that lend themselves better to secure contracts, but it's something that's evolving. I think it's definitely gotten better. People have smart contracts audited, but there's always that risk if you're holding a lot of money in a smart contract, and that applies to just about anything. Let's see here. There's this guy again. I couldn't resist. So yeah, smart contract risk, it could be considered a long tail risk, or maybe it's even more of a prominent risk based on how well the smart contract is vetted. But something to keep in mind. Something more, there we go. Something much more important, I think, because the security aspect will be solved over time. But scaling is the big one, the S word. To me, this is the most fascinating topic of our time, at least in this space. How can we scale these decentralized systems in a way that we maintain all their wonderful properties like immutability and censorship resistance, but scale it to the masses? Bitcoin does like 3 transactions per second on average. Ether does maybe 7 to 10. The Visa network does 3 or 5,000 a second. We need to hit Visa levels if this is ever going to go mainstream. CryptoKitties got very popular in late 2017, and it was kind of a fun little game. It had cute little cats. It turns out, though, they clogged the network, and they made it very expensive to use. So what happened is you had this huge queue of pending transactions, and it was a mess. At ShapeShift, we dealt with this firsthand. We had a really cool DApp called Prism that was like decentralized wealth management, and it was a nice application. However, it became essentially unusable when these gas prices got so high. And that's one thing that we work on now is like, if we're going to release a new DApp, it better be scalable, and we better mitigate these type of threats. So that's a whole other interesting thing. The technology around scaling is evolving at a breakneck pace. Every single day there's something new, and every week there's like a new kind of landmark learning or white paper, and it's almost hard to keep track of what might actually work out over time and what might not. It's just evolving quickly. Scaling is beyond the scope of this talk, but to break it down very briefly, it comes in 2 flavors. Layer 2 is imagine you have your garden variety Ethereum blockchain. And let's say it's not changing at all. It's just the current blockchain. On top of that, you could add a layer 2 system where maybe you're doing something else off-chain. And the central idea here is you don't actually have to be on-chain to do everything. So take some things off-chain, but then when it's time to maybe settle your balance or make a payment, you post it to chain. There's all sorts of ways to do this. State channels, Raiden, Lightning example on Bitcoin is an example of layer 2. I think one of the prior talks was about that. Plasma, zero knowledge proofs, and there's all sorts of things, all sorts of ways to solve this at the second layer. Nothing has really caught on yet because the technology is so novel, but I personally, I've talked to a lot of these teams, and they're all like super freaking smart. They have interesting ideas. I think the key lies in like, can they balance security with UX and like speed? I think that will look vastly different in about a year. And then at the first layer, or layer 1, this refers to actually making changes on the blockchain itself. Some of you may have heard of ETH 2.0. This is an effort to make Ethereum itself more scalable via a switch to a proof-of-stake consensus mechanism, which has some scaling benefits. But more importantly, it's a database concept where you shard the blockchain. Sharding is a database. This is nothing new. It's been around for a long time in computer science. But in the blockchain context, it means that not every node has to process every transaction. So currently, one of the big limitations with Ethereum is like, okay, we have like 9,000 nodes, and they all process all the code. This is very good for security, but it limits scaling. What if there were 100 kind of sharded or split up blockchains that were all connected somehow, but they didn't have to process every transaction? All things considered equal, you would get like 100x scaling benefit as a result of that. So this is super promising, and I think it's where the future is headed, but it's also really cutting edge. Nobody's ever done anything like this. It's fraught with unknowns, and it's going to be implemented in like a 3-phase process. So keep an eye on that. My gut tells me that there's probably, even though you hear estimates of like, oh, yeah, 1 to 2 years, like there's always something that crops up. This is where layer 2 scaling is so crucial. It'll help us scale that bridge between layer 1 and layer 2. So it's a big, nasty challenge, but it's also just very interesting. Incidentally, there's other blockchains that are trying to solve for this, like Cosmos. EOS has decided to be more centralized in order to scale. So you see different ways to accomplish this, but in the context of Ether, there's a lot going on. Real quick, I just wanted to cover the Ethereum ecosystem. This is a picture of the Ethereum Denver meetup. I think this represents, to me, the most important element of the Ethereum ecosystem is the developers and entrepreneurs and participants who are involved in the ecosystem. It's just a very organic, loosely organized, but passionate, global sort of thing. People in this space don't take themselves too seriously. People are focused on just new ideas, and it's generally a judgment-free zone. Everybody recognizes that we're doing something new. So in my opinion, that's the most important element, is like the users and people, just getting into the ecosystem. We also have the Ethereum Foundation, or the EF. So Ethereum is decentralized. There's no Ethereum company. But we have the Ethereum Foundation, which is kind of similar to maybe the Linux Foundation or certain more loosely controlled groups. They're the ones that set up Ethereum initially and conducted the crowd sale. These days, their most important role is to hand out grants, namely around like some of these problems like scaling and security. They have a lot of ETH from the crowd sale still, and their funding plays a crucial role in pushing the ecosystem forward. They also host the annual conference around Ethereum, which is called DevCon. This year it'll be in Osaka. If you ever want to just really geek out for like 5 days, go to DevCon, and it's a remarkable experience. Ton of fun, and surrounded by interesting and smart people, learning tons at presentations, and it's usually in an interesting locale too. Finally, we have Consensus. Consensus was founded by an Ethereum co-founder named Joe Lubin. They're out in Brooklyn. And what's interesting about Consensus, and this is Consensus with a SYS, not a SUS, their approach is just to throw a bunch of stuff at the wall and see what sticks. They've worked on a lot of projects, and it's proven to be an interesting approach. But they actually have some projects that have really become a very core part of the Ethereum space. One is called Infura. It allows DApp users and DApp developers to simplify the process of creating nodes and tapping into Ethereum. It sounds like super boring. It definitely is not an exciting thing, but it provides a much needed service. There's also MetaMask. Some of you may have used that. It's just a little browser app you use that's like an in-browser wallet. And this allows you to easily interact with decentralized applications, whether you're doing like DeFi or Augur or any of these things. And that's been a big leap forward in terms of the user experience. And they're always doing interesting things. They had to downsize earlier this year in response to the bear market, much like a lot of crypto companies did, but they're still doing very interesting things. And then a related project spearheaded by Consensus is the Ethereum Enterprise Alliance, or EEA. If any of you are in enterprise, you might touch on these guys, or you might know about them. The mission of the EEA is really to get Fortune 500 companies on board, whether it's like Intel, JPM, big banks, Microsoft, and get their head around using the technology. Currently, Ethereum really pretty much any blockchain is not very well suited to scaling, but the idea is let's give these companies a sense of what it's like to build on Ethereum. Let's get them used to the language and the concepts, and presumably once public blockchains can provide the necessary privacy and scalability, then hey, okay, these big companies will be in a good position to use it. So it's almost time for Q&A. Just a few parting thoughts. It's like I can't stress enough how fun and exciting it is to learn about this stuff. And if any of you are considering working in crypto, I also can't recommend that enough. It's very exciting. Really, this technology has given us the ability to rethink things from the ground up. Right the wrongs of Web 2.0, move beyond kind of what we have now in the status quo. We're definitely making up the rules as we go along, which can be intense, but also very exciting. One thing to keep in mind is as cool as it is, decentralization is not a panacea. Contrary to what you might have heard in the bull market, like not everything needs to be on the blockchain. You saw a lot of this with the ICO hype, like, we're going to take this AI and then combine it with like VR goggles and please buy our token and we're going to put it on the blockchain. But it's like, why the hell would you want to put that on the blockchain? It doesn't make any sense. So bear that in mind. Like many things work better in a centralized fashion, and there's a relatively small number of things that work better as decentralized systems. Again, let's learn from history, whether it's like the ads market and that experience, or this massive privacy issue that we've come to become so familiar with Equifax, Cambridge Analytica. We're giving up our data voluntarily, but in my opinion, it's a Faustian bargain. There's going to be consequences of this. Blockchains give us the ability to have self-sovereign data and do things our own way. On a more political note, decentralized platforms are a great tool for resisting potentially authoritarian regimes. Authoritarianism has crept across the globe since really over the past 10 years. It's gotten markedly worse, arguably even in our own country. The censorship-resistant aspect of decentralized applications really is a good fit with things that might seek to preserve privacy or provide tools against authoritarianism. And lastly, just to reiterate, this is a brand new field. 5 years is nothing. ETH has been around 5 years. Bitcoin has been around 10 years. In the scheme of things, like say compared to the internet or other well-known technologies, it's definitely still the first quarter. We're really early on. So things could change vastly. We could scarcely imagine MySpace in 2000, let alone Facebook or apps. On a similar note, who knows what things will look like in 3 to 5 years. So some resources here as we wrap up. If you want to learn more, there's other Ethereum sessions. There's one going on right now. He has a site called Chain Tuts. Check that out, Chain Tutorials. Check out a local meetup wherever you are. If you're here in Denver, check out Ethereum Denver. We have a meetup coming up in late September, I believe. There's meetups all over the place, and they're a great way to tap into what's going on. Or attend one of the ETH Global hackathons or conferences. There's ETHDENVER, San Francisco, Berlin, Waterloo, Canada, all over the place. And they're really fun ways to jump in there and really go off the deep end. Did anybody go to ETHDENVER? Awesome. Yeah, so you guys know how it is. It's intense and fun. Don't forget to turn on your bullshit detector and be wary of thought leaders telling you what to think. You see a lot of this on Twitter. So-and-so has been around for, since Bitcoin got started or whatever, and they're very opinionated, and they tell you how it is. And the thing is, even if these people knew it all, which they don't, their knowledge would be outdated in 3 to 6 months because things change so quickly. So don't let anybody tell you, really shape your opinion, or don't become a slave to somebody's idea of this blockchain is better than this blockchain. It's all new technology. We're just trying to create a better and more prosperous and freer world. So do your own research, always question authority, and of course, have fun and be yourself. Thank you.